Alright, hi, Non-Manifold Modeling Systems Human-Centered CAD Library, April 14th, 2009. This was posted on the Cellular National University Computer-Aided Design, and it's in Computer-Aided Design lecture notes for the courseware, and we're on Lecture 9, Non-Manifold Modeling Systems. Non-Manifold Modeling Systems Human-Centered CAD Lab, April 14th, 2009. Manifold model. Every point on the surface two-dimensional. Every point on a surface, two-dimensional. Every point has a neighborhood which is homophoric to a two-dimensional disk. The design is carried out with the abstract shape of the conceptual design that results in non-manifold. An abstract shape is in conceptual design stage equal result of the non-manifold model. Dimension reduction, mixed dimensions, is often used in analysis, resulting in a non-manifold manifold model. Manifold model continue. Design process. Incomplete lower level of description and result in a true solid whose whole design process can be supported by the non-manifold modeler. Non-manifold modeler wireframe, surface solid, cellular mode, and their mixtures can be handled. Manifold model shows these, as you can see. Manifold model continue. If issues developed with a non-manifold model, data structure, Eulers, operators, and modeling commands. Data structure. Masuda's structure. Model is a collection of solids with volume plus laminar face and dangling edge, etc. The entity is called called complex stores. These at list. Compact, easy to understand, and shows a drawing. We have show the complex volume in V1, shell 1, and in faces, loops, edges, and vertex. So that's how you break down the data structure. Data structure continue. Does not provide adjacent information between topological entries, insufficient information adjacencies between faces, difficult to determine whether the shell S1 should split into two, laminar faces should add to the new faces added, can be determined with geometric calculation, but insufficient. Data structure continued. Wheeler's radial edge data structure with the adjacent storing cycle ordering. The manifold model 2 cycles enough. Face to edge cycle, lies to edge of each loop of the face. Vertical edge cycle list of the connected edges to the vertex. Data structure continued. Non-manifold model 3 cycles are necessary. Loop cycle, face, edge cycle, radial cycle, cycle of faces connected with a certain edge, and manifold models of the two faces are at a time. Disk cycle similar to vertex edge cycle. One vertex may have many disk cycles. Show the different vertex A and B, vertex A, B. Data structure continue. Wheeler's radial edge representation stores radial cycle, loop cycle, not disk cycle models or previous slides are represented by the same data can be determined with geometrical calculations but insufficient. In Gerso's and Choi vertex-based representation, disk cycle is stored explicitly. Model region, shell, face, loop, edge, vertex. Model for complex group of regions. Region volume bounded by one or several shells. Single solid has two regions inside and out, and shell is a boundary of a region. Radial edge data structure show the model of the region to model, region to shell, shell to regional, face to shell to face use to shell, face use to face use, loop use, the loop to loop use, edge to edge use to shell, vertex use to vertex use to vertex use to shell. Radial edge data structure continued. Model. Equivalent to complex simple meaning for the group of all of the regions involved. The region equivalent to volume bounded by one or several shells. Single solid has two regions. One for the first inside and the other outside. Shell is orientated boundary surface of the region. Radial edge data structure continued. Additional topological entities, face use, loop use, edge use, vertex use. Similar representation connectivity between loops and vertex edges. A half edges indirectly. Face use inside outside. Face use of face by shell. Loop use, boundary face use, same directions. Face use, edge use, boundary of loop use, vertex use, boundary of edge use. Radial edge data structure, shell greater than edge use, wireframe model, shell vertex use, shell consists of single vertex, loop use, vertex use, isolated point on the faces, it hoops is a whole loop. Her radial edge data structure continued. Edge use, radial pointer points to the edge use on the face use, radial adjacent to the face use given the edge use. The resulting radial ordering faces above the edge can be derived by tracing pointers. Radial edge data structure continued. Vertex use stores vertex edge cycle by storing all vertex use for a vertex. All edge use for connected to the vertex can be derived. The disk cycle is not stored explicitly. And this shows the radial edge data structure continued. Radial edge data structure continued. You have edge function 1, Euler's edge face user 1, edge use mate pointers, edge use radial pointers. Operators manipulate topology. Generalized Euler Poincare formula manifold models. V is equal to the number of closed volumes minus E plus F and R V volume minus E. Okay. Each concept of a composed several volume dangling edge. For manifold cases, V number of shells equals V plus VC. 9 independent base vectors, 9 operators. MVC, CVC may kill vertical complex. Multi-edge vertex, kill edge vertex, may kill edge vertex. Make edge chamfer, make kill edge complex hole. Make chamfer, make kill face, make complex hole. Operators muted with the topology continued. Make center CC, kill CC, center core. Complex, make complex cavity, kill complex face cavity. Make kill vertex ring, make kill vertex ring. Operators manipulate topology. Make vertex kill constrain complex cavity. Make kill volume kill make complex cavity. Make vertex kill cavity. Make vertex volume cavity. Operators manipulate make edge vertex hole. Make kill edges volume hole. Operators manipulate topology. Continue. Make vertex cavity. Make edge vertex. Make edge vertex. Make edge vertex. 2. Make edge chamfer vertex. Make edge face kill chamfer. Make edge vertexes. Then result in make edge chamfers. Make edge flat face kill chamfer. Make face constant cavity control. Constant cavity. Make base vertex kill constant cavity. And those were some more operation topology operations in the non-manifold modeling system.